50 Axis soldiers versus 50 Allied soldiers. A mini battle royale made in Blender and Unity over a few days. I needed to learn the Unity animation rigging package and refresh my modeling and animation skills in Blender and Unity, so I created this. A big thanks to my patrons. Without you, I could not do this, and the game dev tier and up can download this Unity project and have some fun with it. In this video, I'll give you an overview of the steps that I took to create this. I will share important tips along the way to save you time. This was so much fun to create. After doing 10 to 14 hour days, weekdays and weekends for the past 3 months working on the new Line War update, it was fun to have a little break so I could practice some prototyping and refresh my skills in Blender and Unity. Let's get started. I modeled a low poly character in Blender using my traditional style. I like these cartoonish proportions, big heads and chunky limbs. I can't do realism, and I feel that this low poly style is kind of like a modern pixel art. Tip: start with the box and the mirror modifier. Extrude faces to create a character in a T-pose. Keep it low poly for that low poly style and for simpler UV unwrapping. Apply the mirror modifier and make clothes folds a bit asymmetric. I googled some reference images and I found that miniature models, scale models of little soldiers work really good for references. I usually use a simple palette texture to colorize my low poly models because it saves time and effort, but lately I've really enjoyed hand painting textures. First, I UV unwrap the model by selecting edges and creating seams. Think about the seams on clothes. Make cuts around and along sleeves and legs and all the parts of the body. I can't paint with a mouse, and when I moved to Australia, I could not bring my big drawing tablet. Instead, I bought the smallest Wacom tablet I could find, the Intuos Small Bluetooth version, and that works great to paint textures with right inside Blender. A small cheap tablet is good enough to paint textures with. I go through all the steps in detail in my airplane video, but my key tip is to allow it to look terrible while painting. It comes together the further you get, and when you zoom out, it looks pretty good from a distance. I looked at reference images again of the toy soldiers, and well, I should say model soldiers, and I painted them similarly. First, the main colors, followed by details, and then some shading and highlights. I used to be somewhat of a perfectionist, and back in the day I would have stopped painting the textures and started over if it looked like this. But I have realized that once you've layered enough paint and shading on the texture, it looks good enough for what I'm going for. So don't stop, just paint over it until you are happy enough. When you have finished modeling and painting a character, it's time to create an armature and rig it. This allows you to animate the body. Inverse kinematics, or IK, calculates how the legs should bend if you move the pelvis. Forward kinematics, or FK, allows you to rotate limbs manually. The armature is a skeleton that you create in Blender. Once the character mesh is parented and set to be deformed by the armature, animations will make it come alive in game engines like Unity, Unreal Engine, or Godot. Or Godot. That's how I say it. I keep the number of bones to a minimum. It makes it simpler to animate and more performant if you plan to have many characters. I always start with a root or pelvis bone, and I extrude spine bones up. I tend to skip the neck and go straight to the head from the spine. Then I create an upper and lower arm bone. Sometimes I just create a single hand bone for simple low poly characters, but I want to have some control over the hand movement for weapon handling, so I extrude finger bones and thumb bones. I model the hands like a big mitten, so I only need a single finger to control the palm and 4 fingers. Then I create the leg bones and a foot bone. I only use a single bone for the foot. I've tried many times to add toe bones so I can bend the foot, but running animations are usually so rapid and the terrain is so uneven that I don't find it to be worth the effort to animate the feet to that level of detail. For the feet, I add inverse kinematics. I've covered leg IK in many of my previous videos, for example the Let's Model, Rig, Pose, Light and Render a Mech, episode 91 of my 10-minute modeling challenge. Oh, I missed the 10-minute modeling challenge. Oh, it brings back memories. Leg IK makes it much easier to animate run cycles, and rarely do I need to switch to forward kinematics for the legs, so I just use IK. For the arms, it would have been nice to use IK too, but switching between IK and FK in Blender is a pain, so I just animate arms by rotating them instead of through hand positioning. When you've created the limbs on the left side, and provided that you name them with a suffix .l, you can use symmetry to automatically create the bones on the right hand side. Then I select the character followed by the armature, and I press Ctrl P to parent it with Armature Deform and automatic weights. Blender does a great job, and most of the time I don't need to do any weight painting at all. Blender figures out how much the bones should affect the vertices, and that's become really good these days. If you select the character and armature and go into weight painting mode, you can shift click on bones to see how much they affect the mesh. Dark blue means that the bone will not have any effect at all. Green, yellow, orange and red colors indicate all the way up to 100% effect. For this character, I had to change some weight painting around the belt, so I made some tweaks in that area. This was especially important since I modeled some of the ammo pouches as part of the body and separated geometry. Blender finds it a little bit difficult to find the automatic weights for the separated meshes, so I ended up copying the vertex weights from the belt instead. Without too much tweaking, it all looked good enough, and the limbs were moving, hands were moving, and I think it's time to be animated. Actually, before the animation, I made the allied soldier too. I used the same armature and base character mesh, and I changed it to look like an allied soldier. I used more reference images from the model soldiers for modeling and texture painting. Otherwise, the process was exactly the same. I really like using the same armature for characters so they can share animations without problems. I know that Unity supports retargeting of animations between armatures, but that requires you to use humanoid armatures instead of generic ones, and I find it simpler to stick to the generic rig in Unity, and the animation rigging package has, or at least had, some limitations when it comes to humanoid characters. So I keep it simple and just stick to the generic one and share the armatures instead. I made sure to use brighter colors for the allied soldiers, and I keep wondering how they actually told each other apart on the battlefield. I mean, did they just look at the shape of the helmet and the tint of the uniform before they fired their rifle? Not sure. I probably wouldn't qualify. I can't see half the stuff I look at anyway. I should also mention that I modeled and textured the weapons too. I'm pretty sure you won't be surprised that I followed a very similar process. I looked at reference images and modeled a rifle and grenade each for the soldiers. For the Axis soldiers, I made a Kar 98K, and for the Allied soldier, I made a Lee Enfield No. 1 Mark III. Through extensive historical research in the shape of a Google search, I found out those two weapons were used. Then it was time to do keyframe animation. I love to animate, and I haven't found many tutorials on the subject. I mean, how to actually keyframe good animations, so it's been a trial and error process for me. I actually started with a reload animation this time, and now we're coming to a touchy subject. Interaction between a character and an object in Blender and Unity is a bit of a tricky subject. In Blender, I used a child of constraint to parent the weapon to the right hand. Then I could animate aiming the rifle, and since the Kar 98K has a bolt action mechanism, I had to animate changing the child constraint to activate one for the other hand instead, so he could keep the rifle in the same position and animate the right hand without flinging the weapon around. To make it more tricky, you also need to animate the weapon and the way the bolt moves. That is on a separate armature, and when you play back animations on two different armatures at the same time in Blender, it's not so easy to understand what's going on. In the action editor, you have to select the active animation for the rifle, and then you have to select the character armature and set the animation for the reloading action. When you play back, sometimes the NLA editor can have something overriding the animation for the rifle, or it may still not have the correct action set in the action editor, and I think it only comes with practice and repetition before you fully get a hang of what's going on and animating the two things together. You should watch this video to the end, because I ended up not using this animation in Unity because the constraint, reparenting and independent animations did not work together, so I solved that entirely through animations inside Unity instead with the Unity animation system and the animation rigging package. I also keyframed a simple idle animation and a run animation. I can never remember the 4 main frames for the running animation, so I always Google it. I used this as a reference this time, and the beautiful thing is that you can paste mirrored poses and keyframes with Ctrl-Shift-V, so you only have to animate half the run cycle. I have many videos in my channel on this too, for example, the keyframe animation video, where you can see a step-by-step process to do a run cycle. I never animated strafe animations before, and this would be my first time. First, I just did the single run animation in Unity, and I tried to get the character to twist the spine and the upper body and aim towards a target with the animation rigging capabilities. That worked kind of okay, except for anything more than 90 degrees to either side, and especially if a target was 180 degrees behind you. My character became a master contortionist capable of running full pace forward while twisting his spine beyond repair, aiming backwards. It was just not a pretty sight. So I keyframed 8 different strafing animations instead. I reused the normal forward run cycle, and then I modified it to do the sidestepping and the backpedal animations. And I was trying to take into account how the body would shift the weight and straighten the back while moving backwards. It's possible to play the run cycle backwards in Unity, but that looks a little bit odd, and the character leans forward while running back, and it just doesn't seem right the way the body weight would shift. It's important to keep the leg movements in sync with all animations. They will be blended using a 2D blend field in Unity, So when forward run is blended with right forward strafe, for example, the left and right leg must move in the same order and at the same pace. If you were to model the strafe animation with the opposite leg order of leg movement, they would cancel each other out. So start with the same run animation as a template and keep the leg order and keyframe positions in sync. After spending a day of fun in Blender with modeling, texturing, and animation, I exported the 3D model and animations. For compatibility with Unity rotations, it's important to model your character facing in the positive Y direction. That's looking along the green arrow axis in Blender. When you export the character as an FBX file, change the Apply Scaling to FBX Unit Scale and set forward axis to Y forward and up to Z up. When you drag to import the FBX file into Unity, you should select the asset and in the inspector under Model, click the Bake Axis Conversion checkbox and click Apply. Blender and Unity uses different coordinate systems, and this will ensure that the character is facing in the positive Z forward axis without having any rotations to its transform. I also imported the hand-painted textures into Unity and created a new lit universal render pipeline material and reduced the smoothness slider to 0. On the root object of the character, I added an animation controller component and created a new blend tree state called movement. In this blend tree, initially I only added 2 motions, the idle animation and forward run animation. I set the parameter to a float parameter named speed. When you feed the value of speed from a script to the animator component, it will crossfade between the idle animation when standing still and the run animation when moving. I created a basic character C# script where I get the reference to the animator component and the Navmesh agent component, both of which need to be added to the root game object in the inspector for the character first. I created a new method to set a random destination on the Navmesh. In the update method, which runs every frame by Unity, I updated the speed parameter of the animator to the velocity of the Navmesh agent. When the character reaches close to its destination, a new random destination is set. For performant code, you should not really use a string when you update the animator component. You should use animator.string to hash to calculate an integer value instead of using a string, because it runs faster. Okay, it was finally time for the animation rigging package. To summarize what the animation rigging package can do, it adds the capability to add different type of constraints to your character for procedural animations that happens in real time. For example, you can get the character to interact with the environment, hold on to items or aim weapons, like the rifle in my case, just to name a few things. The way it works is that the rig builder component is added to the root game object. Rig layers are added further down in the game object hierarchy, and these layers can have one or more constraints added to them. I've had a quick play with this before, and as I was trying to learn it again, it was a lot of trial and error. I found some great tutorials by the Kiwi Coder. Thanks, he really saved me. And to be honest, I don't think I would have gotten this far unless he had created those tutorials. The way that animation rigs and rig layers work and how you combine them with Unity animations takes time and practice to learn. I was determined not to give up, and I think I spent about 2 days to get to the point where I was happy and somewhat understood what I was doing. I had plenty of times where I was scratching my big forehead wondering why the arms were poking in the wrong direction, why the head was acting like a bobblehead, or why animations suddenly stopped working, or why my hands stopped IK locking onto the weapon. I had to keep reading the documentation, watching continuously the Kiwi Coder tutorials and searching through forums to understand enough. This is very important. The animation rigging concept works in order, so it processes the rig layers and constraints in the order in the rig builder and in the hierarchy within a layer. You add the hand IK last after you've done all the aiming. To cut a long story short, I'll show what I ended up with in this little slow motion sequence here. The rig builder component is on the root game object of the character. For each weapon, I created a hierarchy of rig layers in order. A base rig layer to hold the weapon, an aim rig layer that could be activated when the soldier finds a target, a right hand IK layer, and a left hand IK rig layer. And these two could actually be on the same rig layer, but I had them separate for animation purposes. For each weapon, I created this hierarchy, and at the top I have the weapon itself. It is parented to a pivot game object, which is at the stock of the rifle. First I had parented the rifle to the right hand, but that did not work because the bolt action reload animation requires movement of the right hand without flinging the weapon around. So after hours, I learned that you can actually parent the stock of the rifle to the shoulder bone instead, and voila! Freedom to animate both hands for reload animations without reparenting. I have two grip game objects that the hand IK uses to target the hand positions. And I also have the rifle object itself, a child object to that, which is the bolt for the reload animation, and a muzzle positioning object that I use to raycast from when a bullet is fired to detect if it hits anything. Then comes the first actual rig layer. It contains a multi-position constraint that positions the rifle at its pivot point to the shoulder.r bone transform with an offset. Then it has a multi-parent constraint that constrains the pivot point to this transform that has just been affected by the position constraint above. Without this rig layer, the weapon would just float at the feet of the character. The actual positioning of the hands are done later by the two-bone IK constraint for the right and left arms. They target the hands and move them to the RH grip and LH grip, which are children of the rifle. Again, it is important that the two-bone IK constraint comes last in the chain. Then we have the weapon aim rig layer. It has multiple constraints. The first one positions this rig layer transform itself to the right shoulder bone. The second is a multi-aim constraint that turns spine 2 towards the target with a 60-degree offset. Then there is a multi-parent constraint that parents the pivot point to this transform. I understand if this makes no sense to you as you watch this video. It took me 2 days of banging my head against the table and I still don't fully understand it. So be patient and don't feel bad if you feel like a deer in the headlights of a bullet train. The next set of constraints for the aim rig layer is the multi-aim constraint for the pivot point of the weapon. This actually points the rifle itself towards the target, not just the body that we were aligning before. The next constraint is a multi-aim constraint that rotates the head bone to align to look at the target. The target is actually just an unparented transform that follows the position of another character. The animation rigging system does not like to update values from script without rebuilding, so to switch target I decided to just have a permanent game object as a target that I position every frame at the same position of another targeted character. Then we have the final rig layer, which is the body recoil. I had to record this many times because in my first attempt, my soldier waited so long to fire that he ended up getting shot himself. I switched to the allied soldier and he suffered the same fate straight away. So I went to a third soldier to capture the recoil and he decided to throw a grenade instead. He would have ran onto his own grenade only if he wasn't saved by the final soldier that gave him a helping hand to avoid the grenade. I set up everything again and at this point I was eager to show the recoil, but another soldier turned to aim and I was sure I was going to miss the opportunity again. But he fired at someone else, so I finally captured the firing sequence. You can see the override rotation in the inspector being animated, but unfortunately he hit his target and lowers the rifle so you can't really see the recoil after all that. Anyhow, the point is that you can use the Unity built-in animation to animate values of a rig layer and animate the rotation offset of the spine, in this case, to simulate recoil. For the reload animation, I actually used the built-in Unity animation system with the Animator controller on the base of the character to animate the position and rotation of the RH grip child of the weapon. The right hand IK automatically tracks that transform and animates the hand. Since the weapon is also a child of the character, I can animate the bolt action with the same animation, so the character and weapon animations are automatically played in sync. Explosions! This deserves its own video, so I'll only mention explosions briefly. I created a sphere with a fluid simulation in Blender set to fire and smoke, and I tweaked some of the settings. Then I added a particle system to the same object that emitted particles rapidly for just a few frames in all directions. A larger box was also set to fluid, but this time the type is set to domain. These two in combination with a principled volume material can bake great explosion animations with transparency. I rendered 100 frames of the baked explosions to PNG files with a resolution of 512 by 512. I've finally stopped paying for my Creative Cloud subscription that has cost me over $7,800 over 10 years. So I can no longer use Photoshop, but it feels good to have ended that. It was way too expensive. Oh, I can't believe I paid that much. And as a Blender user, I embrace the open source and free alternatives, so I installed GIMP finally, and knowing that I was going to feel a bit lost in the interface for some time, I still managed to do the basic task of creating a 2048 by 2048 texture, and I dragged 16 selected PNG files that I liked from the 100 rendered frames into a texture atlas. The images were rendered with transparency, and I saved the atlas as a TIFF file because transparent PNG files have a problem with white auras around the transparent edges because it doesn't save all the color information for the alpha channel, so it assumes it to be white. So TIFF it is. In Unity, I imported the texture and set alpha is transparency. Then I created a material with the render mode fade and the color mode overlay. These material settings are pretty important because initially it might look good with transparent render mode, but if you have fog, you'll notice a white box around your particles, so it's better to use fade. I also set main options for the material to flip book frame blending. When you play the animated frames in the particle system using the flipbook frame blending, it crossfades between the textures for less of a stop motion type look. Finally, I created a particle system that emits a single particle with a texture sheet animation to play the whole sheet with a custom curve to make it play quickly during the fire phase and slow during the smoke phase. This is an extremely performant animation, and it's only a single particle, one quad mesh with one texture, and you could play literally 1,000 of these without any problems. Okay, that was a small lie because I actually emit 4 particles with slight delay and randomized distribution just to have a little bit more dynamic looking explosions. But still, the performance is very good. Haha! So, take that. I think this deserves its own video, because I should do a step-by-step tutorial instead on the explosions. Very nifty stuff. Unless it's me coming off my motocross bike, or any situation in real life to be honest, ragdolls are always fun in video games. This is another topic that deserves a dedicated little video, because it's not really that complicated to make them. The only thing that requires some scripting is to make sure that when a ragdoll is instantiated, it inherits the position and rotation of limbs and props like the helmet and weapon. I used the built-in ragdoll creator in Unity to create the ragdoll prefab. When a character is hit by a bullet or affected by an explosion, a method on the character called die is called. Gruesome. The die method instantiates the ragdoll and moves it to the same location as the character it represents. The ragdoll prefab is inactive when it's instantiated because I need the hierarchy to match the character hierarchy so it can translate the positions and rotations before some of the objects, like the helmet, is unparented from the ragdoll so it can fly independently and not be affected by the ragdoll headbone. That was a long sentence. Sorry about that. After the rotations and positions have been translated, the ragdoll game object is activated and any force that was sent as an argument to the die method is applied. In this case to a random limb to simulate a hit in an arm or a leg. Finally, the original character and its AI navigation and target tracking objects are destroyed. The explosion forces are applied a little bit differently to the ragdolls. Once an explosion is instantiated, it calls the die methods on characters within the blast radius, but the force cannot be applied straight away. The ragdoll needs to be instantiated and get a chance for the colliders and rigid bodies to be initialized. The explosion script invokes a call that is delayed by 200 milliseconds to a method that applies explosion forces to any nearby rigid body objects. Before I finish this video, I should mention that instead of just having the characters running around on primitive surfaces, I sculpted a little dirt diorama in Blender with some trenches, craters and ridges. I made the mesh 50 square meters, and once it was imported into Unity, I added a collider and baked an AI Navmesh so the characters could find their way across the terrain. The AI and Navmesh components used to be included by default in the Unity editor, but nowadays you need to add them as a package. And then you add the Navmesh surface to a game object, and any children in that hierarchy can be used to represent a navigatable surface. Alright guys, I hope you enjoyed that video. It was a lot of fun to create. It was nice to do something a little bit rando, different for a change. Just some prototyping, back doing some Blender stuff, doing some Unity things, a lot of fun. And I was happy to be able to put this into a video and share it with you guys, so I hope you liked this format. If I was trying to do a tutorial out of this, it'd probably be like a 20-hour step-by-step tutorial because there's so many things to cover in that case, tying all the components, the prefabs, the modeling, the texturing, the rendering, the explosions, the AI navigation, everything like that together. but hopefully like the overview like this will give you a pretty good idea of what's involved when you create it. And this has been uploaded to my Patreon, so you can download this project if you're a game dev tier or a high supporter on my Patreon. And I just want to give an extra big shout out to all you guys who are supporting me on Patreon. I know it's been a little bit quiet on the update front lately, been working so hard on Line War. And it's a bit ironic because I put so many hours into the Line War development, day and night, pretty much 10 to 15 hour days or 14. And commercially, it's not really the smartest thing to do. But that's going to be it for this video. I hope you can give it a thumbs up if you like the video and subscribe if you haven't already. And I'll see you in the next video. Take care until then, and I'll see you. Bye for now.